This is a video for problem 1.3, and in problem 1.3 you will be learning about equivalent fractions in a number line. So we've learned about ratios, the comparison of two quantities, and now we're going to kind of transition into looking at how ratios can also be used on a number line, or in this case we're going to have these things called fraction strips. So what you see here, these are the fraction strips. I made them for you, and we'll use this sheet of paper as we do this lesson. So with this lesson, just follow along with me. The first thing you should do though is take out your spiral notebook, label, right hand corner, so we're on problem 1.3, and today is October 16th. So in this video, it talks about sixth graders are going to be, you're going to be making these strips, and they're going to be folded for you. But we'll use the ones that I've already made. So if you look at the sheet that you have for me, you can already kind of start to see that there are some equivalent fractions on the sheet of paper. So really what you just look is to see where the lines match up, and then you have an equivalent fraction. So fractions that are equivalent represent the same amount even though their names are different. So you can have fractions that have different names but they mean the same thing. So here would be an example. If I take my highlighter here and we highlight 6/12 is the same as 5/10 is the same as 4/8 is the same as 3/6. So if you look at your sheet, I've tried to make them so when you look down, 4/12 equals 3/9, which equals 2/6. So you can see some equivalencies already. So we're not going to spend a lot of time. You can investigate that further. I'm going to get into the problem here. So on your paper, you will label problem A. So we're right here, problem A. And some of these you can just answer in your head, or if you're working with a partner at your group. So it says use strips of paper 8.5 inches long. Each strip represents one hole. So this is one hole. Or we can say this strip right here, excuse me, this strip right here from this edge all the way to this edge is one hole, and I just happen to have the 12ths. I divided them up as good as I could. So one strip represents one hole. What strategies did you use to fold your strips? Well, you didn't use the strategies. I did that for you to save time. How can you use the half strip to fold eighths? Well, if you look at your strip, we're looking at B here, B1, how can you use your half strip to fold the eighths? Let's find the half strip. So the half strip is right here. So it's just cut in half or folded in half. How can we use this to fold the eighths? So would you fold it in half? If you fold a half in half, you have fourths. If you fold the fourths in half, again, you have eighths. 8 equal parts. B2, the picture below shows students' halves, fourths, and eighths strips. So here's a half, fourths, and eighths. How does the size of one part of a half strip compare to the size of the part of the eighth strip? So how does the size of one part of a half strip, that's this, how does that compare to one part of a eighth strip? Well, if we go down and look at the eighth strip, well, the eighth strip, half of a fraction strip, the half strip, would equal 4/8. 1, 2, 3, 4 out of 8. So you're just getting some visual looks here. Number 3, what fraction strips can you make if you start with a third strip? Well, if you look at the third strip, so think about the third strip, 1, 2, 3, or 1, 2, 3 equal parts. If you take the third strip and you chop each of these in half, right? I'm just going to do this half, half, half. What will you have? If you go up, you can see, oh, I've got 6. 1, 6, 2, 3, 4, 5, 6. Okay, so this paper here, once again, just helps us see equivalent fractions. So what strips can you make if you start with a third strip? So before you answer that question, really look at what lines up with these thirds. Okay. Number 4, which of the fraction strips you folded have at least one mark that lines up with the mark of a 12th strip? So you're going to look at the 12th strip right here, and you're going to look for ones that line up with any on the 12th strip. Moving along. C. In earlier grades, you used number lines, such as the one below, to share whole numbers. This is a number line, and there's whole numbers through 4. Now you can use fraction strips to mark points between whole numbers. So if here's 0 to 1, that would be 0 to 1. Now they stretched it out. You can use fraction strips to understand the distance between 0 to 1. So C1, some students began to make a number line using their 1/3, 1/6, 1/9, and 1/12 strips. The drawing shows their work so far. One student used the top fraction strip to mark the 2/3 on the number line. So here's 0, here's 1. They used their third strip to mark 2/3. Name 3 other fractions here that are equivalent to 2/3. So if you follow the 2/3 down, name these fractions that are equivalent. You could also think of it as moving up, finding the ones that are equivalent. In this case, the 2/3, and you can see them. So you can use the one in the book or the one that I've given you. Name another fraction that's equivalent to 2/3. Now I'm down on 2. If you have used a fraction strip to name a specific point between 0 and 1 on a number line, how can you find equivalent fractions for the same point? So if we know that this is 1/3, how do we figure out what these fractions are? Wouldn't we figure out what the whole is divided into? In this case, it's 1, 2, 3, 4, 5, 6, and then count 1, 2, 2, 6 lines up with 1/3. D. Some other students began to mark a number line using different fraction strips. Use their drawings to measure the distances between the points. For example, the distance between the mark labeled 0 and the mark labeled 3/5 is 3/5. So 0 to 1, here's 3/5, which is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 6/10 is equivalent to 3/5, and you can see it on the number line, and you can see it with the different fraction strips. So for here, you're going to find the distance between each pair of points. What's the distance between 0 and 7/10? 0 and 7/10. Figure it out. What's the distance between 3/5 and 7/10? What's the distance between 7/10 and 1? And 3/5 and 1. Problem 2. What is the distance between each pair of points? So you're just using different fraction strips, finding equivalencies to answer A, B, C, D, E, and F. Last but not least, name 5 fractions equivalent to 4/12. So you could take this out, look at your 12ths, follow them down, find equivalent fractions that are matching. Name 5 fractions that are near but not equivalent to 4/12. How can fraction strips, number lines, and thinking with numbers help you find equivalent fractions? Matt claims that 1/3 can indicate a point on a number line as well as a distance. Is he correct? Explain. In E5, Sally said that the fraction strips remind her of rulers that you can use fraction strips to measure the progress of a fundraising thermometers. What do you think? Could you use these fraction strips, maybe if you turned them, could you use them to measure thermometers, like the thermometers used to represent the goals of the 6th, 7th, and 8th grade from the problems last week? So, in this video, I went through the problem with you. You can pause along the way. Good luck.